In this short video, we are going to see closures in Swift. A closure is a self-contained block of code that can be assigned to variables, passed as arguments to function, and can be returned from functions as well. If you have worked in .NET in the past or in Java, you may have heard about the word lambda. So closure is similar to lambda or anonymous functions. So when we see the examples, we'll be able to see what exactly the closure is and how exactly it works. So I'll give you some simple examples to understand the concept as well. The syntax, we have the parameters followed by the return type and followed by this keyword in. And then we have the statements of the closure. We will be able to see this in a bit. Now let's see the samples which I was just mentioning about. So this is the first example, a simple closure. So first we are defining the closure. So the name of the closure is multiply closure and the signature is that it accepts two integers and returns a int. And we have seen the definition, how we define it. We are defining the arguments followed by the keyword in and then the statements which are there. Okay, so for example, it shall be returning the multiplication of the two arguments which are being provided. So if I execute this closure, like multiply closure 3 cross 4, I'll be getting 12. And then there is a shortcut of representing it as well. So these are the arguments, $0, $1. If there are three, then it will become the third argument will become $3 and so on. So it can be like in a shortcut way, instead of writing all these things, defining all these things, you can simply write uh, like this also. And it'll be adding the two things and giving you the result as 7. So this is the first program. So first what I need to do is I need to compile this, which I can do by writing Swift C followed by the name of the program. For executing it, I have to write the name of the program, which is without the .swift, which is the binary file which is generated after the compilation. So if I run, the first result is the multiplication, which is 12, and the second result is 7, which is the addition. Now let's go to the second example. So similar example here, you have an array of names and you want to have them sorted. So you can write a closure like this. So again, the same definition, name of the parameters, return type, followed by in, and then the statements which are there. And then you can have this printed. So it's if you see here, it is in the reverse way. And if you want to have it in a sorted way, ascending sorted way, then you can have the same thing represented in a succinct way. Instead of writing all these things, you can just write parameter first is less than parameter 2. So again, to compile the same thing, so what you have to do is Swift C, and then to execute you have to write the, and you can see that we have these things sorted in ascending and descending order. Now let me go to the third program, which is this. So here, because these are very commonly used functions, so I have listed them out here for you. So map, filter, and reduce. So map. So what we are doing here is for every array component, we are squaring it because we are multiplying the number with the same number. So all the numbers one by one sequentially from the array would be taken and multiplied, and you would be getting a new numbers array. Okay, that is what is squared numbers. So, and this map function helps us in doing that. So map would expect this kind of closure. Okay, return value is int and the the parameter is also int. Okay, and the second way you can write the same thing is by this way. So here, if I have to double the number, I am writing 2. If I had to do the same thing, I would have done $0 into dollar 0. Okay, so if I run this now, so So you can see that this has been generated now. And like I said, if I put a $0 here, then it would, the first and second would be same. This would also be a squared. It won't be a doubled, it would be a squared again. Okay, so for running this again, I need to compile it one more time and I need to then execute it. So you can see that both are same, squared again and squared numbers. Filter, if you have to filter the array for some condition, you can use filter. So again, how I'm taking a modulus, and if it is zero, that means these are even numbers. So this is the filter which will give the even numbers, and for odd numbers, the modulus shall be 1. So same thing we see here. So even numbers are like this, and odd numbers are like this. And now finally reduce with the help of closure. So we would be reducing the array to a single integer. So how we do it is, again we have the result. Result is basically the result which is expected, and the initial value is 0, and every time the result would be the operation, the previous operation. So first time it will be 0, next time whatever operation, 0 plus the number, then second time whatever had come, that would be the result plus the another number. So basically, because we are doing an addition here, it will be the sum of all these numbers, whatever is the sum of all these numbers. And if I do a multiply here, multiply will give me what? It will give me a factorial of 10. So that's what we are seeing here. If we add all these numbers, we get 55. And if we take a factorial, it will be this much. So this is a completion handler, and this is defined like this. Okay, so you have defined a type with two input, a result and an error, and it returns void. And then what you do is, you have defined a function which expects what? It expects a completion handler with string. So this T, which is a template, would be string. Now what happens is, there is a dispatch queue which runs after 2 seconds, and then a random boolean is generated. If it is true, you return a success. If it is a failure, you return a error. And then finally this closure runs. Okay, in case of success, this part runs. In case of failure, this part runs. uh, the other thing important to note here is that we have put a escaping here. So escaping will give us whether the lifetime of this closure is beyond the lifetime of this function. If you put escaping, that means it is the lifetime is beyond the execution of this function, and that's what is required in this case. You want this closure to be available post the execution of this function also. Okay, so it's a asynchronous, like I said earlier, because it is going in a thread here. So we may see this first, because this function execution is delayed by 2 seconds, and post that we can get other print statements like this, and like this. So let me execute the last one. So this is, again, I need to compile Swift C, and then I need to run it. So yes, so this time the Boolean returned this place. It was not a true, so that's where it went here. Now if I run again, let's see what it gives. Again, it gave. I'm running one more time, and it gave the random value again. Went to the error clause, and it went one more time to the error. Finally it has gone to the success. So yeah, randomly whatever you get, and you get those details. So this is the closure which we have given, and the definition of closure is what? It is completion handler, and completion handler has yeah, the result, and it returns what? It returns a void. Okay, so these are closures and very important concepts in Swift. uh, Yeah, I would be putting these samples in Git and putting the link in the description. Thank you very much.